Hello, in this video I want to show you how you use the simulation where you build your own circuit. And this is the PHET simulation when you pull it up in the assignment or also on the website. And I'll just start building some random circuits. So I pick the stuff from the toolbox, the battery, also I like this better this way. And then we build some cables or wires, we connect them, they connect automatically. And just build something here. And if I want to have electricity flowing, I need like a closed circuit. So I will connect the wire here and go down to this end of the bulb. And now I go from that end, and I'll just take the shortcut here. It's not nice, but it works. So I have a circuit here, and I can also remove that. And add a switch, for example. Now nothing happens. There's no current flowing. But if I close this, now current is flowing. That's how it works. If I want to add a second one, okay, I do this. Okay, for example, if I don't follow the circuit rules, if I just attach one thing here, nothing happens for this. There's no current. I always need a closed circuit. So if I want to close that circuit, okay, I can maybe do this, and that works. So now I have the two connected. There's a circuit flowing through both. And if you want to know if this is now in series or parallel, just go to the theory, and maybe we can identify if the light bulbs are kind of in series, like the electrons go first to this first resistance and then the second one, or if they're here, we see how a parallel circuit looks like. The current comes and splits into the two. And sometimes in the actual circuit, it looks not quite as clean as here. And then it can be a little bit more difficult, but let's see if this is parallel or circuit. It looks like it's going here, and parallel to that, yeah, this is a parallel circuit. If I want to make a circuit in series, then the easiest would be to, let's put this away, delete this. Also, just to show you, just one, okay, maybe I've shown this, but if I just have one, the electrons can't flow through that bulb, so that's why nothing is happening here. Okay, now let's build one in series. Let's clean up the circuit a little bit. So that means after, or the electrons flow here, after this they go here, and then they continue here. This would be in series, and it doesn't matter if I move this around, this is still in series. So the electrons flowing, or they flow this way, they have to go through one first, and then they continue to this. And here we see the light bulbs are less bright than they were in parallel, because now they have to share the original. Okay, let's find out how much volts do we have here. There's a voltmeter, and I take one end here and the other one here, and now I see minus 9 volts. Usually we can ignore the sign, because if I would have this here and this here, now it's plus 9 volts. So it always just depends on the voltage between these two and one, and that's why the sign really matters, how the orientation of these two. So 9 volts. So now let's just check the voltage on each bulb, and we see for this bulb it's 4.5 volts, and let's check this one. It's also 4.5 volts. So now this 9 volts, they are split between 4.5 in each bulb. Let's compare this in series. Okay, let's build this. I clean this up a little bit. Okay, this will be one, and then the next one we put here in parallel. There it is. So now they are already brighter. Let's measure the voltage here. 9 volts. and 9 volts. So now both have 9 volts when they are in parallel connection. So that's how you measure voltage. Voltage, you just go next, the device where you want to know how much voltage is there, you measure right next to your device. Your device is between, or if I want to know, okay, how much volts do I have on the battery, I put the battery between. If I want to know what's the voltage between one spot of the cable and another one, I can just do this, and here we have 0 volts. That makes sense. There is no voltage on one cable, but now if I go here, now we have the bulb between. Now I have 9 volts. It doesn't matter if I measure it here or here. That's how you measure voltage. Now let's see how you measure amps. The ammeter goes in series of your device where you want to know how much amps are going through this bulb, for example. Okay, I delete this and I replace the wire with the ammeter, and now it shows me, oh, I have 0.9 amps going through this. This replaces a wire. So it must be in series with the device where you want to know how much amps go through. So I still don't know how much goes here because this only shows what's going this way. So if I want to know how much go here, I replace that with an ammeter. And I see, oh, it's the same. 0.9 amps. And we can do one more thing. I'll delete this. Delete this. Let's put a bulb in series. That would be this. So now we see it's already less bright. Oh, we also already saw, oh, now the amp went down. So now all this is one series. So that means 0.45 amps go through this bulb, but the same amps keep going through this one. So I don't even need to measure it here. But if you want to know for sure, you want to verify, just double check one more ammeter, and it's the same. That's how you work with this simulation. You can play around and try more stuff. Maybe you want to try how does it work with these switches. Let's say in a room, you want to simulate that's your room with the one bulb. Oops, I deleted the bulb accidentally. And here would be a switch. Okay, now in your room, maybe you have 2 switches. Let's do this. One more switch up here. Okay, now, oh, you can't turn it on here right now, but now I can turn it on here, and now I can decide where I turn it off, here or here. And of course, that is not how the circuit is wired in your house, because in your house, if both are like this, you would have to go to both switches to turn it on, and that gets a little bit more tricky. Maybe you'll find this online. I don't want to show it to you. It's it has a certain name that you have actually the options to switch on and off on either switches. But I want you to play around with this a little bit and see how circuits work, and get familiar with circuits and apply the theory, which is shown here in clean, all nice and square, but then in reality it can look a little bit confusing at times. All right, I hope you can do the simulation now by yourself and play with this a little bit.